Okay, so we are going to talk about how to find correlation coefficient using a calculator. Now, I am going to be specifically talking about a TI 8384 for this and how to do it with that. So here I have a data set. It is the price for the dozen eggs and the price for a gallon of milk. And so what we're going to talk about is how to now put this in on a calculator. So let me pull up my calculator here. And so I have this emulator here that's basically going to show you all the buttons that I press over here on this screen. And then I've got what you should see on your screen. So the first thing we're going to do is we're going to press Stat and Enter. And we want to be able to put our data set into L1 and L2. So I'm going to put my price of eggs straight down the list in L1. So I'm just putting in each of my prices of eggs. Now, I do need to put their connected or associated price for the milk in L2. So I've got 1.69 and then 3.43. I'm going to do 3.52, 3.50, okay, so now I've got all of my associated prices. Okay, now I am going to do, quit out of this because we do need to set something up. So I'm going to press the mode button. And here's what should come up on your mode button. Now, what you're wanting to find is down here, and you may have to scroll down on your calculator, but you're looking for the stat diagnostics, and you want to turn those on. So you want to toggle over and then press Enter to get that to turn on, okay? So we want to make sure this is what's going to allow us to see our value. Okay, so now I'm going to do quit. Now, the good thing about that set diagnostics is once it's turned on, it's on. Okay, and you do not have to turn it on again. So you won't have to do that step any other times, and you'll see where I don't have to do that step on another when I move on to another example. So I'm going to press the word stat again. Remember, I've already entered my data. You can always go back and look at it. There it is. But we're going to press stat, and we're going to arrow over to calc. So we're going to arrow over where it says calc, and then I'm going down here to option number 4. We're going to pick this lin reg, and we are going to make sure that it says L1 and L2 right here for our X and Y list, and then we're going to press enter or toggle down until it says calculate. Now, the only thing we are concerned with right now is this R value. Okay, this is the one that we need. The A and the B will come up for the next section, for section 4.2, but for right now, we just need the R value. So the R value for this data set is 0.2631. Okay, so we're at 2631. So we know that this is positively associated, okay, which means they were going up a hill, but it's a fairly weak connection, okay? It's only at a 0.2. So if we look at the, and this was coming off of the worksheet, if we look at part B, it says in a month where the prices of eggs is above average, meaning when we think about that graph picture, if eggs was higher, what would I expect the price of milk to be, above or below average? And I would expect it to also be above, because as these go higher, the milk prices go higher. So I would expect it to also be higher. Now, it asks, which of the following is the best interpretation of the correlation coefficient? So option number 1 is when the price of eggs rises, it causes the price of milk to rise. We've already talked about that correlation is not causation. So if it says one thing causes another, that's not our choice. So option 1 is out. Option 2, when the price of milk rises, it causes the price of eggs to rise. Again, I cannot choose a causation thing. It doesn't matter if this was weak, strong, or perfect. The correlation indicates the price of eggs tend to go up and down together. That one is true, okay? So now I'm going to put underneath here another data set, and this one is going to deal with systolic and diastolic. Okay, so I'm going to get this over here. I'll bring my camera down so you can see it a little bit better. Okay, so we're going to be working with this data set that has our systolic and our diastolic blood pressures. Okay, and so we're again going to talk about how to put this onto a calculator. Okay, and I'm going to show you a couple of things on our calculator. One is we need to talk about how to clear our data. Okay, so I'm going to first off press clear so that I don't have anything on my screen. I'm not going to see anything. I'm not going to try and reread something that was there before. I'm going to go to stat and enter. So here is my data set back up, but I don't want these data points. So what I'm going to do is I'm going to arrow up in a list until I have the name of the list L2 clear listed or highlighted. Then I'm going to press the clear button and the enter button. So clear and enter, and that is going to clear everything in that list. And then I'll move over and I'll go up to L1 and I will press clear and enter for that one. Okay, so now I have my list cleared. So I'm going to go back in and I'm now going to put in the systolic. So 113, 119, 157, 108, 112, 107, 123, 110, 118, and 116. Whoops, looks like I missed a couple of them in there. After 107 is 123. And then the last one was 116. And now I'm going to go partner pair. I'm going to go up and over, and I'm going to do the diastolic. So 77, 69, 103, 69, 75, 71, 77, 74, 88, and 70. So now I have my systolic in L1 and my diastolic in L2. Now, again, I indicated that we only had to do that regression, that stat diagnosis, turning it on one time. And so it is still already on because it's like a light switch. It's on until I turn it off. So from here, I'm just going to press stat. I'm going to go straight over to calc. And, and I'm going to go down to option 4, which is LinReg. And again, I'm going to press enter enough times until it will show me my values. Okay, so for this one, okay, again, the only thing I need right now is my R value, and I have 0.8628 if I was going to go to 4 decimal places. So we would have so now we are still positively associated, but this one is a fairly strong. Okay, so if it would have asked me how strong are we it is, I'm at 0.86, so I am really getting up there. So we're going to have a fairly strong linear association, which means picture-wise, I'm probably looking at something similar to this. There will be a little bit of wiggle off that line, but not a whole lot. And so then this one says if someone's diastolic, so remember this was systolic, our Y values were diastolic. It says if someone's diastolic pressure was below average, so it's moved down, would I expect the systolic pressure to be above or below? Since this one is down, I would expect the systolic to be below average as well. Okay, so since diastolic was low, systolic would also be low because this is positively associated. When positive association, we have when one goes down, the other is down. When one goes up, the other is up.